So, friends, in this session we are going to be covered the variance. In the last session we have covered the mean and the probability, total probability in the case of a binomial distribution. We have also seen that in the case of a binomial distribution, mean is going to be depend on the two parameters. One is a n and second is a p. And we have also seen that the total probability is always equal to the 1. In this session we are going to be covered the variance. So you know what do you mean by the variance that we have seen in unit number 2. So variance is nothing but it gives the measure of a spread of variables with respect to the means. In that session we have seen that if the variance is small, then it is close to the mean value, and if variance is too large, then it is far away from the mean value. So that's why the variance gives the spread with respect to its mean value for overall the description. We also seen that the variance is always denoted by using a letter var of x, and this is equal to the e of in a bracket x minus e of x square bracket whole square, right? And if you simplify this, then we will get a e of x square minus e of x whole square, and this e of x is nothing but it's a mean in the case of a binomial distribution, and this is equal to the np, right? We have already seen the proof of mean for the binomial distribution in the last session. So we know this value and we do not know this value, so we have to first find out this value e of x square, and we are going to be subtract the mean value from the e of x whole square, right? So let's first find the e of x square, right? So just we are writing the e of x whole square. This is nothing but it's a summation of x square into p of x, where x can take the values 0, 1, 2, 3 dot dot till n, right? So we are putting this value 0, 1, 2, 3 one by one in this problem, and this p of x is nothing but it's a probability function for the binomial distribution, which is this is equal to the ncx p raised to x q raised to n minus x, that we have already seen, right? So we are just putting these values in this formula. So first value is 0, so 0 multiplied by anything is going to be always 0, so we are directly write this as a 0. Then next value is a 1, so when we put the 1, then 1 square that is going to be remains as it is, and when we put 1 in a probability function of a binomial distribution, then we know that we get a np q raised to n minus 1, that we have already seen in the last session. Okay, so the next value is a 2, so 2, since it's a x square, so that's why it's a 2 square, and we will get a n minus 1 divided by 2 factorial into p square q raised to n minus 2. Okay, the next value is a 3, so that 3 square into n minus 1 n minus 2 divided by 3 factorial into p cube q raised to n minus 3 plus dot dot dot, what is the last term? It's a n, so it's equal to the n square into p raised to n. Okay, because this is going to be 0, so anything raised to 0 is equal to the 1, and n6 is always gives you the 1. Okay, so we will get a n square into p raised to n. Okay, so we are just first simplifying this equation. We are just try to delete this 2 raised to 2, 3 raised to 2 with respect to this 3 factorial. So we are able to delete this one of the 2 from this, then one of the 3 from this. Okay, so what will be the remains after simplifying? This is 0, so no need to write down again. 1 square is going to be always a 1, so again we can omit that. So what is the first term? It's a n p q raised to n minus 1. Okay, then in the next term it's a 2 factorial, so 2 factorial is always equal to 2, and this 2 square is equal to 2 times 2, so we will delete or we can cancel out one of the 2. So what will be remain? It's a 2 n minus 1 p square q raised to n minus 2. Okay, again this 3 square is nothing but it's a 3 into 3, and this 3 factorial is nothing but it's a 3 into 2 factorial, right? So this is nothing but it's 3 into 2 factorial, so we can cancel out one 3, then what will be the remaining? It's a 3 upon 2 factorial, right? And this 2 factorial is nothing but it's a 2, right? Because 2 factorial is equal to 2. Then the next term is remaining, it's a n minus 1, n minus 2 into p cube q raised to n minus 3. Okay, and plus we know that the last term is a n square p raised to n. Right now, if you carefully observe, same as that of the mean, here you can find out that two terms are common. One is a n and second is a p. So we will take common terms outside the bracket, square bracket. Okay, n and p. So what is remaining inside the bracket? Since n and p we have taken outside, so the remaining is a q n minus 1. Okay, then again, since we have taken a 1 n and 1 p outside the bracket, so what will be? It's a 2 n minus 1 p q raised to n minus 2. Okay, plus 3 by 2 as it is. We have taken 1 n and 1 p outside, so what will be? It's a n minus 1 n minus 2 p square q raised to n minus 3 plus dot 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 dot. What is the last term? It's a 1 n and 1 p is outside, so it's a n and p raised to n minus 1. This will be remaining in the square bracket. Okay, right now we have to adjust this term in such a way that we will find out the equation in the form of a p plus q raised to anything. Okay, p plus q raised to anything. So here we have seen that the first term is n raised to 1 and the last term is n p raised to n minus 1. So we can, if we carefully observe, then we are able to write down this term in a form of a p plus q raised to n minus 1. Okay, so we are trying to adjust this equation which is written inside the bracket in a form of a p plus q raised to n, and whatever the term is remains, that we will take in a separate bracket. Okay, so the first is a np, then take a square bracket, and inside the square bracket we are taking the curly bracket, and in a curly bracket we are writing the equation in the form of a p plus q raised to n minus 1. Okay, and the remaining remaining terms we are writing in a separate curly bracket. Okay, so first we are writing as it is, that is a q raised to n minus 1. It doesn't matter. Then here we just want one term of n minus 1, p plus q raised to n minus 2, right? So we are writing only one term because we have seen the formula for p plus q raised to n. So same way we can find out a formula for p plus q raised to n minus 1. So you can write down you can expand this p plus q raised to n minus 1 in your own in the last formula that we have seen, that is mean is equal to np. So from that you can find out how to find out a p plus q raised to, or what are the various terms that can becomes in a p plus q raised to n minus 1. Okay, so since it comes the two times, so we are writing one term in this bracket, that is a n minus 1 p q raised to n minus 2, and the remaining terms we are writing in the next curly bracket, that is a n minus 1 p q raised to n minus 2. Okay, then next term is a 3 by 2. So this 3 by 2 is nothing but it's a 1 plus 1 half. So we are writing the half term over here, and we are writing the whole term in this separate bracket. So it's a n minus 1 n minus 2 upon 2. This 2 is nothing but it's a, you can say also 2 factorial. Okay, p square q raised to n minus 3. Okay, and the remaining complete terms we are writing over here, that is a n minus 1 n minus 2 p square q raised to n minus 3. So again, if you add these two terms, then you are going to be get a same term. Okay, so we have already adjusted this term, and the last term is this. So the last term is going to be we just want a p plus, we want what we want, it's a p raised to n minus 1, right? So what will be the remains? the whole term is a n p raised to n minus 1, and we want only a p raised to n minus 1. So what will be the remaining term? It's going to be a, what is the last term is going to be remain? It's going to be a n minus 1 p raised to n minus 1. Okay, so again if you simplify these two terms, then you will be get a same term. Okay, so again we have simplified this term, we have divided this term, or we can say it's this equation in this form. Okay, so if you carefully observe, then this inside curly bracket, this terminology in the form of a p plus q raised to n minus 1. So we can directly write down this as it is. So it's going to be a p plus q raised to n minus 1. Okay, plus whatever the remains is going to be in the next bracket. So again in the next bracket, if you carefully observe, then you can find out that there are the two common terms, that is a n minus 1, n minus 1, n minus 1, it's a one term, and next term is a p and p. Okay, so in each and every term you are going to be get two terms, that is a n minus 1 and p are the common terms. So we are taking that is outside the bracket n minus 1 into p, and what will be the remains is going to be written inside the curly bracket. So what will be the remainder? It's a q raised to n minus 2, right, plus n minus 2, 1 p is already outside, so it's a p, and q raised to n minus 3 plus dot dot dot, what will the last term? It's going to be a p raised to n minus 2, right, because this already we have taken 1 p outside, so the term is remaining, it's a p raised to n minus 2. Okay, so again if you carefully observe, this is always equal to the 1, because p plus q is nothing but it's a total probability, and this is always equal to the 1. So we can directly write down this, because 1 raised to anything is always equal to the 1. So we are writing here as it's as a only 1. Then n minus 1 into p, and again if you carefully observe, then this in the form of a p plus q raised to n minus 2. Okay, and again this is the total probability in the case of binomial distribution, which is equal to 1, and 1 raised to anything is always equal to the 1. So what will be get? It's a np inside the square bracket 1 plus n minus 1 into p. Okay, and if you simplify this, then what will be get? It's a np plus n into n minus 1 into p square, right, and again if you simplify this, then you will be get it's a np minus plus this is gives you the n p okay, so this will gives you the n square p whole square, and next is a n p square, right. Okay, so this is the formula, or this is the expression we will get for the e of x, right now we are putting this in this formula. Okay, so what is we will get? It's a variance is equal to variance of x, which is equal to np plus np whole square minus np square, minus we are putting the mean over here, so this is equal to the np whole square, right. So we will cancel out these two terms, then what will be remaining? It's a np minus np square, right. Again if you carefully observe, then you will be get a you will find out that np is a common, and what will be? It's a 1 minus p, and 1 minus p is nothing but it's a q, so what will remain? It's a npq. So this is a variance in the case of a binomial distribution. So hope you understand this whole derivation for the variance in the case of a binomial distribution. So we have already seen that in the case of a mean in the case of a binomial distribution, which is equal to the np, and the variance in the case of a binomial distribution is always equal to the npq. So we will stop here. So thank you.